All right, this is Unit 3, Lesson 2 homework. As you guys know, well, you might not know more about quality than quantity. It's only two problems. Let's go into the first one. Philip made a sign for his classroom door. He made the width 1/4 foot and the length 1/3 foot. What is the area of the sign? That's when you want to ask your kids, what is the key terminology in this problem? Because we want to be practicing close reading strategies. I encourage you to read the problem more than once, identify the key terminology, then devise a plan to how to go about solving the problem and then execute. So encourage your kids to do this. First thing you want to ask them, what is the key terminology in this problem? They should be telling you, I know the width is 1/4 foot. I know the length is 1/3 foot. And then you need to ask them, well, how do you calculate the area? And they should be able to tell you by now that area equals length times width. All right, so let's get into this problem. Width, 1/4 foot. The width is 1/4. The length is, the length is, the width is, The width is 1/4 and the length is 1/3. All right, so the first thing I want them to do, I didn't even have to write that down, that was dumb. But the first thing I ask you to do is draw a shaded area model representing this problem. So your kids should be able to, first thing that they would want to do is open up a big rectangle, because these are like rectangle area models. All right, and they should recognize that, okay, our width is 1/4, and our length is 1/3. So our problem is really doing 1/4 times 1/3, which in another way of saying it is 1/4 of 1/3, or vice versa, 1/3 of 1/4. Get used to exposing your kids to how it connects. The word of is really connected to the word to the math. Of is really connected, especially when you're talking about fractions. It's connected with multiplication. Okay, so let's talk about this one. Let's think of 1/3 of 1/4. So let's go ahead and represent our 1/3. Well, let's do the fourth first. A 1/4 of 1/3, because you can do it either way. So let's say your kids should be like, well, how can I represent that 1/4 first? And they should be able to tell you, oh, I know, I could separate our rectangle into fourths. So let's go ahead and do that. All right, I separated them into 1/4, but I still haven't represented 1/4 on here. I should probably shade. Your child should be able to tell you, oh, in class we were shading the 1/4, and we shaded lightly. And then now, how do I represent 1/3 of that 1/4? And encourage them to use it with opposing lines. I just feel like it's easier if you do the second fraction or the first, do the two fractions with opposing lines. It's easier to represent in my mind. So, sorry, I dropped my pen. We're going to represent 1/3. They should be able to tell you, oh, I could separate this whole thing into thirds, and we can do it the opposite way. So it's easy to represent. All right, so I'll represent thirds. Now I got my 1/4 represented, and now I've separated into thirds also. I hope that doesn't confuse. I should probably turn these over so you know that 1/4 is represented here, 1/3 is represented there. But okay, so I represented my 1/4 here, and I want to represent 1/3 of that 1/4. So at this point, your child should be able to recognize, okay, I remember in class when we were representing 1/3, we just take one of the thirds and we could go ahead and shade that. So notice when we shade this part, isn't this representing 1/3, one whole shade of the 1, 2, 3. So this is 1/3 of the 1/4. And then your child should recognize, wait a minute, this part right here is double shaded. It's extra dark. And they should realize, Mr. Oliver told us in class that represents our answer. Our answer is the double shaded one because that's where the two of them meet. So it's 1 of the whole. Let's see what the fraction of the whole is now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now that's 1/12. So our answer would be 1/12 because it's 1 of the 12 of the whole. Okay? So let's go on to the next problem here. Because I'm more about just having not too many problems. I just want them to be getting, also for this problem, I want them to write and solve a multiplication expression answering this problem, which are two numbers, or 1/3 and 1/4. So I'll just write those down. And they want to write a multiplication expression representing those. So it could go either way. They could do 1/4 or 1/3, either one. But you want them to recognize that when you multiply, when you're trying to find out the fractions, all you really got to do for multiplication is just multiply straight across. Okay? So we got our fractions. 1 times 1 equals 1. 3 times 4 equals 12. And of course you get that for both. And then they should be able to draw the correlation like, oh, wait a minute, that's what we saw on our area model. So this is just another way. And you all, parents, you know your kids better than anybody. So you might notice that it's easier for your child to represent it this way. Or you might realize that your child is much more of a visual learner and they're strong, they feel more stronger and confident representing it with the shaded area model. But I would like them to get acquainted with both methods so that they could use one method to check the other one. So when they see problems like this, they could straight up know, yeah, we multiply straight across. But if I'm having trouble trying to figure out if I got it right, I also have another tool. I have my shaded area model that I could draw and see if I got it right, to use that to check the other method. All right, so that's kind of what we're doing. We're trying to develop tools in our toolbox. I'm going to go with the second problem. Sierra has sticky notes that are 1/2 foot in width and 1/4 foot in length. What is the area of the sticky notes? And I want them to do the same thing with this problem. I want you to draw a visual model first. All right, so they should know by now. They know area equals length times width. Let's draw a rectangle representing our area model. And the dimensions are 1/2 a foot in width and 1/4 foot in length. So we got to recognize, maybe we could represent our 1/2 first. Let's make it easy. We could represent 1/2. And your child at this point should know, okay, if I'm trying to represent 1/2, all I really got to do is split it in two. Let's do that here. So you kind of want to split it in two, and then you want to shade your area that you're dealing with. Like this is what we're talking about. We're talking about 1/2, and now what we want to do is find 1/4 of that 1/2. So keep drawing that correlation between of and multiplication. So when we get on the EOG, they can know when they're seeing fractions and they're seeing of between them and of right after fractions, 9 times out of 10, it's going to be talking about of. Okay, and the same thing when we're talking about division of fractions. When you see terms such as shared equally or equally share, equally divide, that's going to tie into division. But for now, multiplication. Now we want to ask your child, how do we represent 1/4 of this 1/2? So, they should be able to tell you, okay, I can separate it into fourths. And encourage them to use the opposing lines. I just feel like it's easier. So, boom, we did 1/2 this way. So let's do 1/4 this way. And they should be able to draw this for you. All right, so we separated into fourths, but I don't know, how do I get my answer? How do I represent 1/4 of this 1/2? So I separated into fourths. Let's go ahead and color our 1/4. Because it's split into fourths, I'm going to color this one of these four. Okay? So now we're coloring, and I can look and be like, wait a minute. hold on, there's a part that's double colored. Like this part is double colored, it's darker than everything else. That should be able, that they should know that's our answer. So let's go ahead and look. Let's see what we get for our answer. 1 of how many? 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 1/8. All right, and now the next thing, like the last problem, I would like you to devise and answer a multiplication expression answering this problem. Okay, so we did it with our visual area model. Now let's just do it straight up like paper wise, you know. So we got our numbers is 1/2 and 1/8. So it's 1/2 times 1/8, 1/2 of 1/8. Multiply straight across. That's what I like about multiplication of fractions. I think multiplication of fractions is actually like, it's way, to me it's the, I won't say that. I'll just say, to me it's a lot easier than addition or subtraction because you don't have to find the common denominator. All you do is multiply straight across. If your child is having problems finding multiplication, I would encourage you to work with them at home on their like their multiplication tables. If you need me to send home some multiplication table homework, I could print some out like that easy. Just let me know. You can drop that down in the comments. All right. But okay, let's multiply straight across. 1 times 1 equals 1. Oh, I'm sorry. I did the problem wrong. I wrote 8. Oh my gosh. Your kids know how much I mess up in class also, so they should understand. I make a lot of mistakes. But 1 times 1 is 1. 2 times 4, because the original problem was 1/2 times 1/4, equals 1/8. So at this point, your child should be like, okay, I got 1/8 both times, and they should know why this works. Because I could easily teach a kid and be like, oh, all you got to do is multiply straight across, you're good. But that visual model is showing them why that works. Because when you actually break down the fraction and you're seeing, okay, this is why that works. Because you might be thinking, how are we getting a smaller number when we're multiplying fractions? Wouldn't you think the number would get bigger? But that visual model gives them like a way to see like why this works when you multiply straight across. All right.